Question 9 on last year's final exam deals with this area function. A of x is the integral from 1 to x. So we're using x, our variable is the upper limit of integration, and we're integrating this height function, t times t minus 1, with respect to t. Okay. So it's basically the area between the graph of this function and the x-axis over this interval. And we're just, x, the variable, is changing what the length of that interval is. Okay. So we're first of all asked to evaluate a of 1. That would be the integral from 1 to 1 of t times t minus 1 dt. Well, as soon as I see that my limits of integration are the same, I know that I'm integrating over a degenerate interval. There's basically no base to this shape, so that's going to give me 0. Okay. Now, if I'm evaluating a of 4, that's the integral from 1 to 4 of t times t minus 1 dt. Now, in order to evaluate that, I'm going to want to actually do that multiplication. Because remember, unless we're able to do some sort of a u substitution, we don't have a nice way of dealing with products, at least not at this point in our mathematical career. So what we need to do is just do the arithmetic, do the multiplication. This becomes t squared minus t. And now I can just take an antiderivative because I'm just using the power rule for each piece. So that's going to be t cubed over 3 minus t squared over 2. And that's all evaluated between 4 and 1. So that's going to be what I get at 4 minus what I get at 1. So at 4, I'm going to be getting 64 thirds minus 16 halves, which would just be 8. And then at 1, I'm going to be getting 1/3 minus 1/2. I think I'm going to go ahead and just get a common denominator of 6 for all of these fractions. So that would be 128 sixths minus 48 sixths. Now here, as I get a common denominator of 6, I'm also going to distribute that negative. So that's going to become minus 2 sixths and then plus 3 sixths. The negative makes it a plus. Okay, so let's see. 128 minus 48 is going to give me 80. Minus 2 plus 1 is going to make it 81 sixths. And of course I can reduce that because 3 goes into both of those, so that's going to just be 27 halves. So that's my a of 4. Okay. Now, a prime of x, let me give myself a little bit more space here. A prime of x, we're just taking the derivative of this area function. Now notice the t here is really a dummy variable, because if I evaluated this, just like I did over here, I'm going to find myself an antiderivative, and then I plug in the limits of integration. So when I plug in the limits of integration, I'm plugging in 1 and x here, I am really getting a function of x. Okay? So this is taking the derivative with respect to x of this, and the fundamental theorem of calculus tells us how this works. It tells us that differentiation and integration are essentially inverse processes. And so if I have a setup like this, where I'm taking the derivative of that area function, I'm just going to get the height function. But of course, it's going to have to be a function of x, because the area was a function of x. So I just copy that height function with the t's replaced with x's. Kind of nice. Okay. And then the last question we were asked was, what is a prime of 1? Well, that's just going to be 1 times 1 minus 1. That would be 1 times 0. So that's going to just be 0.